Just waiting to see green or red, actually. There it is. Perfect. Pushing the live now tweet. Yeah, I forgot to do that last week. All right, here we go. Switching back over. Got lots of windows going around here. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. Not everyone who joins the roundtable is specifically a PHP developer, and that's a good thing because there's so much we can learn from other developers outside of the PHP community. In fact, the developers joining us today are JavaScript nerds who have really cool perspective on approaching problems using this JavaScript library called ReactJS. Now, we don't assume that you, the listener, knows much about ReactJS, so we'll try our best to fully explain the concepts that we're discussing so that even a complete newbie will have enough information to take their learning further with a good Google search. If you're listening live, I want you to be a part of this conversation. So to send a tweet to PHP Roundtable with a question, and we'll try to get your question answered if we can. You may have heard of React PHP, which makes non-blocking stuff easier to do in PHP. But you may not have heard of ReactJS, which is a JavaScript library for building user interfaces. And it's not your typical JavaScript library. In fact, it's got one wild and crazy way of rendering markup to a user's web browser. Now, you'll probably hate it at first once you learn about the React way of writing HTML, but hang in there with an open mind. This is the same code that runs Facebook's user interface and a bunch of other big websites, so maybe it's not all that bad. We'll also go a bit further and talk about a design pattern called Flux, and we'll see how Flux can be used with ReactJS to write beautiful JavaScript code. So we've got some great guys sitting here at the round table. In no particular order, I've got Lee Byron here, who's the designer and engineer at Facebook. He's been there for 7 years, and he's a core contributor to Immutable.js and ReactJS. Welcome, Lee.
Hey, thanks for having me.
Thanks for coming on. We also have Spike Brim, and he's a web engineer at Airbnb and working on Isomorphic JavaScript. What is Isomorphic JavaScript?
In a word, it just means sharing code between the browser and the client, and it's something that React makes really easy.
Excellent. And I actually learned that term right before we came on air, and I'm excited to talk about it a little further because I alluded to it in the show notes, and I didn't even know it was called Isomorphic JavaScript. But I've already been doing it, and I didn't even know that's what it was called. So just a heads up, we're going to be going a little out of order in this episode. I generally like to start off by defining basic terms and explaining the topic progressively, but Spike will have to cut out a bit early, and I'd love to hear his perspective on how Airbnb implemented ReactJS on their front-end stack. So there's a bunch of terms like flying over your head probably at first, so just hang in there, and we'll be sure to go over them in more detail a little bit later. So actually, I want to kick it off with Lee.
Sure.
You had a mention about the history of Facebook's front-end stack and how React was sort of born. Where did React come from? From Facebook, right?
Yes, from Facebook. So let's see, what's the best way to explain this? So React is really a culmination of a lot of ideas that have come together at Facebook over the last couple of years, and started with this desire to have everything live on the server, which seems counterintuitive to what React is. It's about being able to build rich applications on the client. But actually where this started was in PHP. So Facebook's whole middle tier is built in PHP, which should be relevant for you guys. And we've actually taken PHP to some next levels with both new virtual machines to replace Zend, as well as furthering the language. So hip-hop is both a VM, and then hack, which goes along with hip-hop, the language that actually is similar to PHP but has some significant differences. But one of the very first pieces of syntax that changed about PHP with hack was called XHP. And you can actually plug XHP into regular PHP. And if you guys haven't checked this out yet, you should. It's super cool. What XHP lets you do is define PHP classes in terms of XML fragments. And what this let us do is build basically templates of HTML, basically what would become the output to the client browser, But rather than doing it in terms of strings that would get concatenated together and making sure that we were encoding and escaping things in the right places as we're concatenating these strings together, what XHP does is it gives us a actual data structure, a tree with these classes that are children of these classes, where each attribute and each child is a particular type. So when you string the whole thing together, everything escapes properly. You don't have to worry about any of it as you're assembling it yourself. The library takes care of it for you. And the vast majority of the XSS holes that we had, which we were playing whack-a-mole with up until that point, all vanished in really, kind of a single coterie architecture. So XHP powers Facebook's site today, and it really started doing that in about 2009, thanks to Marcel Laverdat, who built XHP. And most of our JavaScript attempts were really about making as little JavaScript as possible. Keep the browser lean, keep the payload small. We wanted to really maximize performance more than anything else. And XHP came to be about 2 years ago. And really, the JSX part, and I know some of these terms are new, but we'll explain some of them later. JSX is the syntax addition to JavaScript that was inspired by XHP. So whereas XHP is an extension to PHP to add XML fragments that really just compile down to PHP, JSX is the same idea. It adds XML fragments to the syntax, but really they just compile down to JavaScript objects. And what that let us do is the exact same technique that we were doing with PHP, rendering out ultimately HTML strings, but ensuring that along the whole way, escaping was happening in all the right places, and XSS holes were basically not possible. So that basically is where React came from, the evolution of Facebook's front-end stack from PHP and XHP as an addition to that, and then our JavaScript stack sort of expanding over time to handle more rich client interfaces. And then JSX really came later after we had assembled React, when we kind of had this aha moment that this code that we were writing that was pretty gross looked a lot like the PHP code that we were writing in 2008 that was pretty gross, that we were able to replace with XHP. And that's where JSX comes from.
Nice.
Was that clear? Hopefully it was.
Absolutely. Actually, Spike, I muted you just because you had some background stuff going on, but are you able to unmute yourself? I don't want to have you not be able to chime in when. Yeah.
Absolutely.
Okay. Just wanted to make sure I didn't have God mode on or something that prevented you from unmuting. Yeah, that's really cool. The XHP thing that you mentioned was something that Anthony Ferrara on Twitter just pointed it to me. I totally forgot about it, and yeah, it takes HTML syntax basically and compiles it down into PHP stuff. That our PHP class is a lot like JSX does. We're going to be talking about all these specific terms in a little bit, but if you had to define what ReactJS is in a nutshell. Spike, how would you define ReactJS in a one-liner?
Yeah, sure. So I think React really boils down to this concept of the virtual DOM. And this is a pretty novel concept that React introduced, and it's been kind of revolutionizing the JavaScript world lately. But the virtual DOM is all about constructing a representation of the DOM in pure JavaScript, just in memory, and being able to do transformations on it and query it and mutate it and doing all these things, and then only later basically turning into the real DOM. And so what we're used to doing for the last 5-10 years is directly working with the DOM, mostly using jQuery or something, right? You find some class selector, you change some attribute, you change the HTML inside of it, and you're always going to the DOM to read from it, to determine if a certain class is applied or whatever, or if a certain value, what a value of a form field is, or you're going to it to write to it to change an attribute or something. And that is problematic for a number of reasons. And one of the big reasons is performance, because it turns out that a lot of people think that JavaScript is slow. It's actually really, really fast these days. V8 and is the Google engine that's in Chrome, and there's Nitro and Safari, and Mozilla. Firefox has been getting really fast too. And so it turns out that what the bottleneck is for most JavaScript applications, it's not the execution of the JavaScript, it's in the DOM itself. So it's in part of it's the interface between JavaScript and the web browser actually mutating that markup. And so what virtual DOM lets you do is it separates those two concepts. So with virtual DOM, you can describe using JSX, for example. You can basically write what looks like HTML, but it's pure JavaScript, and you can do all this cool stuff with it, and then compile it or update the DOM based on that. And then one cool thing that falls out of that for React is that with React, you describe, it's almost stateless. So you describe what a component looks like at a given moment, given certain variables, like certain state. But you never manually write the state transition code. So you're never writing like add class to this or ask if this class exists on this div and swap the, you don't have to do any of that boilerplate that you have to do with Backbone or jQuery.
Yeah, that's so annoying.
Transformative. It's like really special because that lets you do really cool performance optimizations. It also just makes it much easier to write maintainable, stateful components because you just let the library take care of all the rest of that through the magic of virtual DOM.
One thing I'll add to that, that was a really great explanation of how all that comes together. Well, what the code ends up looking like is really, really similar to what your code looks like in PHP when the output is just to echo some HTML out to the browser, right? Like you write some code that says, in this condition, I want to send this HTML. In that condition, I want to send this HTML. And it runs on the server, and it outputs the HTML to your browser. The idea is you should be able to write code that looks really, really similar to that, but every time the data changes in your application, you just re-render the entire application. Similar to like web circa 1999, where you like click a link and it goes back to the server and it like re-renders an entirely new page. That's the concept. Under the hood, it's doing a lot of performance optimizations, but the idea is that we re-render the entire app anytime anything changes. And so in that way, it really looks much, much similar to server-side code than client-side code.
And it really simplifies a lot of that state management stuff.
Exactly.
And you can try to compare and contrast React's approach with like Angular or Ember, and they've taken different approaches in the past. For example, with Angular, there's dirty checking, right? So if you have some value that's changing over time, the JavaScript in the browser just checks to see if that value changes over and over and over again in a loop. And if it does, then it'll try to change just that part. Whereas with React, what's the best way to express this? Basically, anytime state changes, rather than relying on that dirty checking, as Lee said, you re-render the entire application, which sounds slow and it sounds ridiculous, but you're just doing it purely in JavaScript, and then you diff that virtual DOM with the actual DOM. And so if there are any changes, the React library will compare what the new state in virtual DOM with what exists and just do the minimum set of mutations to make that happen. Is that a good way of explaining it?
Yeah, you mentioned Angular, and a lot of people will try to compare directly ReactJS with Angular, Ember, Backbone, or something. Is it really fair to kind of compare those in as a whole, or were you making a comparison of like one aspect of those JavaScript libraries?
I think that was more of a comparison of the way they deal with the view layer, basically, and components, reusable components. I think there's a pretty good one-to-one comparison there. Although in general, Angular has more built into it. Like it's got more than just the view layer. It's got some other things, whereas React is very tightly scoped to be just the view layer, which I think is actually a big benefit for it.
So we can just think of React as basically just the view layer, and we can use whatever framework we want in the back end, right? Whatever is our favorite flavor of JavaScript framework. So it's not a matter of like switching to React.js and off of your framework, but it's adding it as a component to optimize your front end. Is that a way of thinking of it?
That's one way to think of it. We don't call it a framework; we call it a library because libraries are intended to be used together, whereas frameworks are intended to be organizing principles for your application. React has some aspects of framework in that it does help you organize your application. But really, it's designed to pair well with other libraries. So people have paired it with different libraries that help with data structures. They paired it with different libraries that help with views. They paired it with different libraries. You can use it with Lodash. You can use it with all kinds of stuff. But of course, you can kind of like layer in these libraries in Angular and Ember and all these as an after effect. But it's not going to change the overall structure of the code that you write. When you're writing Angular code, you're writing Angular code. When you're writing Ember, you're writing Ember code. With React, you're just writing JavaScript, and you just happen to be using the library to do so. So React has lots of places throughout that let you sort of like click together with other pieces. And we do that on purpose. You know, at Facebook, we have tons of other libraries that we need to interop between, and the different product teams at Facebook all have their own thing going on. So it's actually really important to us to be able to maintain that, and it's also ended up being pretty valuable in open source land too.
And that's been good for us because we've been using Backbone and Handlebars since 2011 or so. So we've got tons of JavaScript that's Backbone views and Handlebars for templates, for client-side templates. And that's worked pretty well, but then we end up having those same problems where as it gets really hard to manage a stateful component, right? As state changes, you end up having to have these weird dependencies and manually update the DOM. And so what we've been able to do is in one of our big Backbone applications is we're just starting to drop React components directly into it, and like kind of page by page or component by component replace the Backbone and Handlebars code with React code, and it fits just really nicely in there because it's just pure JavaScript.
That's awesome. That state, when you mentioned handling state, that's something that really attracts me to functional programming, where maintaining state is done a little bit more elegantly than the way that I would typically do it, especially when it comes to JavaScript. I have my nice PHP backend, and on the front end I just have what I call a mess of jQuery. And basically I'm sitting here trying to maintain state from AJAX calls and all these other types of sources, and then I'll try to maintain like the state of the DOM. So like maybe a button needs to be read with this type of text in it when this state happens, and then it needs to be this with another one. And so I end up with all these functions that change the state of certain components to try to like not make it just all over the place, but still there's no way of really knowing what, when you're in the DOM, what changed what. Can you give me an example of how, like, say, maintaining the state of a button after an AJAX call would be handled with ReactJS versus maybe jQuery or something?
I can talk about that a little bit. So first of all, you have to talk about who owns what. This is a concept that comes up a lot in React of, you know, what React component owns that piece of the DOM. And when you write jQuery code, often there is no owner. You have a lot of different functions that all can operate upon that DOM node, but no one piece of jQuery code is like the owner of it. And this actually really important property that React has is that there's only ever one owner of a DOM node because there's only ever one place where that thing can change. And because of the component model, you can have you know, components can be children of other components. So you can compose together some really rich user interfaces and still end up with a one-to-one mapping between a given DOM node on the page, like a button, and then the component that handles it. So when you say, you know, the component changing as a result of an AJAX call, no, that doesn't ever happen. A button state only ever changes as the result of React re-rendering. Now, React might re-render because you told it there's new information, and there happens to be new information because somewhere else you did an AJAX call. But the AJAX call never directly touches that button. And then that's like the core piece.
That's probably a good place to mention Flux. Right?
Sure. Yes. So what React gives you is the view layer, and then it gives you a view model. So we can go over this concept of state later in React. But basically what that is a view model, assuming that the components are tiny little state machines that can kind of, you know, change their state and re-render themselves. But any data that's coming in from the outside, especially AJAX requests, needs to be handled somewhere, and React has no opinion on how to do this. It just says, give us JavaScript objects, and we'll, you know, render them for you. So Flux is what's the right? It's not a library, although there are libraries that implement the Flux pattern. So let's call it a pattern. It's probably closest to relate it to MVC as a pattern, right? There's no library called MVC. There are many libraries that implement MVC. So Flux is a pattern, not a library. Facebook has a Flux library. There happen to be a whole bunch of other Flux libraries that are really awesome as well. But it changes the data flow such that data only ever flows in a single direction. You can still have cycles, but it only ever flows in a single direction. There are no two components that flow back and forth between each other. And basically what that means is like it is the opposite of two-way binding. Two-way data binding is doesn't fit into the model of Flux, which is, so an example of how you might use a Flux, here's like our hello world in Flux, is we have a React component that renders us a button. When we click the button, we want to do some AJAX request. When the AJAX request comes back, it's going to like change some data in our data store, and then we're going to re-render, which maybe it'll change the color of the button or something like that, right? So when you click the button, Flux creates what's called an action, and that action describes something that's going to change in your application. It may be backed by an AJAX request. It might not be. Oftentimes it is actually backed by an AJAX request. So it's going to do go to the dispatcher. The dispatcher is kind of like the central point of command that controls the whole of Flux. So it goes to the dispatcher decides what to do with it, so it might then execute its AJAX request to come back with more information. The dispatcher then takes the result of having executed that action and gives it to what Flux calls stores, which just means kind of like any bag of data. And stores manage actions come into the store. The store might change something about itself. So maybe our AJAX request came back and said all buttons should be purple now. So it might update its store to say, color is purple. And then it can emit out an event that says the data store has changed, which then React can connect to that. So the data is now continuing to flow back down to React. And so then we've flowed in a single direction from clicking a button to creating an action, flowing it to the dispatcher, back and forth between the server. Then the dispatcher speaks to the store, and then the store speaks back to the UI. So it only ever flows in that one continuous loop.
I ran into quite a bit of trouble trying to implement Flux into my own application. And I do have some specific questions a little bit later, but I wanted to kind of talk about some specific real-world implementations because I primarily use PHP for my backend stuff. But when I started implementing ReactJS on a particular project, I started to realize that I was pretty much just building a web API in PHP that JavaScript would make AJAX calls to, and then just dump the state on my ReactJS app to re-render the DOM. And I started to ask the question, is all of this, all of my domain logic being moved from the back end to the front end to the client side? And in this particular instance, it definitely was. And I was just basically using PHP for persistent storage. Now, does that sound about right for a typical small web app? You're just basically using you're just using a backend for persistent storage, and everything, all the main domain logic's on the client side?
It can be. It doesn't have to be. Certainly that's a pretty popular way to do things. Actually, the popularity of that particular technique explains why parse has become an interesting thing that people are finding value from. All parse gives you is a dumb backend that stores data and gives you a little bit of control over how that data is manipulated when you call API requests, right? But it's not going to render stuff for you. It's going to do anything like that. It's only your API layer, your persistence layer, like you were describing. And then it's assuming that all of the business logic and the rendering is going to happen on the client. That's certainly one way to do it. It's not the only way to do it. And I'm sure Spike has some stuff to talk about isomorphic JavaScript, because this really comes up then when I want to render out my application at some point in time such that the Googlebot can find it and index it appropriately, or I want that HTML to get to my browser as fast as possible, and I don't want to have to wait for all my JavaScript to download and render stuff for a UI to appear for performance reasons. These are a few of many, many, many reasons why being able to render on both the client and the server is really valuable. Spike, you wanna add more there? I don't want to let you.
Yeah, you mentioned isomorphic. Yeah. That's your forte, right? Isomorphic, this idea of making sure that the JavaScript's able to execute in the back end and the front end on the client side.
Yeah, absolutely. And basically, the whole way we got to this topic is a really good way to set it up, because a lot of us have gone through the same process in building our client-side apps. Maybe we were a PHP or a Rails developer, then all of a sudden we build out a JSON API, and then we realize that all of our app is basically in JavaScript. All the business logic and domain logic turns into JavaScript. And then pretty soon, what we have is a really fat JavaScript app and a really kind of dumb backend. And in many ways, it's a nice, easy way to write. It's a good separation of concerns, but then you end up running into these kind of bad side effects of that. And it's what Lee mentioned. So a lot of times what that ends up meaning is your entire application just gets rendered client-side, right? And that's easy and that's pretty fast, but then SEO becomes a concern because your backend can't render any JavaScript, and then that initial page load performance gets really bad, and the page load is slow. And that's what led us to investigate the idea of running our JavaScript app on the server side. So as soon as Node came out, we started playing with this and looking into it, and we started doing this before React was released. So we were doing this at Airbnb. We released a library called Render, R-E-N-D-R, and it did this with Backbone and handlebars. And so what was cool about it is we took our Backbone app, which was a typical client-side Backbone app, and we pulled it down to Node.js, and then all of a sudden, any link into our app, like any page of our single-page app, could be fully rendered server-side. And this was huge for us. This was a really cool like realization for us that we could make this happen. And our mobile website does this currently. But then I started learning about React, and I talked to Pete Hunt, who was on the React core team, and he actually came over to the Airbnb office. And in the matter of like 30 minutes, we were able to connect React and Render together because they were very complementary. And we basically swapped out the Backbone and handlebars part with Render or with React, and realized that React is like the perfect view layer for an isomorphic app because
That's really cool.
It's built from the ground up to allow rendering on the server. But it's not enough to just render JavaScript to a string on the server. I mean, and that's what React does. But when you serve that string of JavaScript or string of HTML from the server, the browser can use it. It's a full page and everything. But you want to be able to reattach to that same HTML that the server sent with the JavaScript. Like the easy thing to do is to just throw away everything that the server sent you and then re-render on the client side. But that has some problems. And what's amazing about React is that they solved that use case from the get-go. And what we're starting to see is a lot of big companies and just a lot of independent developers using React to render isomorphic apps. And so a really notable one would be Yahoo. So recently, Yahoo, you may have noticed that they deprecated YUI, Yahoo user interface, which was like a huge part of the web for a long time, decade or so. And they deprecated it because they weren't getting much use out of it anymore. But they realized that, and they started adopting React. And they recently rewrote all of Yahoo Mail, which is a giant app, like really high traffic app, using isomorphic React. And so they can render any page of the Yahoo Mail inbox fully on the server, and then in the client side it becomes a full-fledged single-page client-side application. And they also use Flux as well. So as Lee mentioned, there's different implementations of the Flux pattern. Yahoo implemented one called Fluxible, which is an isomorphic Flux. And so it's super cool to see Yahoo standing on Facebook's shoulders and taking these concepts even further. And we're seeing Netflix adopt a similar approach. I've heard rumors that Facebook is maybe doing something similar, and at Airbnb we're doing the same thing. So
yeah,
I think it's a really interesting time in the JavaScript world right now. I think in a few years it's going to be the norm to have all of your JavaScript be server rendered.
Yeah, like I said, our backend is in PHP. Of course, in order to make this isomorphic, you need to be able to run JavaScript on the server. So we actually have the ability to call out from PHP to another service that's just, it's not even Node. So React doesn't have any dependencies, and what Node gives you is V8 with a whole bunch of really rich libraries and tools built into it. It turns out that we don't actually need any of those to do to render from React. All we need to be able to do is put data in and get data back out. So we just run V8. So we can call out to V8, which is just that's the guts behind Chrome, and tell it to load in a particular React component, put some data into it, and then tell us what the HTML back out should look like. And then we can put that back into our PHP environment, connect it with everything else. Because in our case, React tends to be portions of the page and not an entire page. So we can assemble it back together with non-React pieces and then send it back out to the client and then wire things back up on the client.
This sounds amazing. V8? You're running V8 on the server?
So V8 is the guts of Chrome and also the guts of Node. And you can run it from a command line. If you download and build V8 on your machine, you can type V8 space whatever file contains JavaScript, and it will execute it very similarly to how Node executes it. And what Node gives you is, like I said before, a lot of really rich libraries and tools built on top of V8. But certainly if you just want to run JavaScript, right? Like none of the stuff that's in Node lives in the browser, and React is fully capable of working in the browser. That's the point. So you actually only need V8, which will run with a slightly smaller footprint than Node proper, which is why we're doing it that way.
So you still need Node then?
You don't need Node.
There's a lot of different bindings also to V8 in different languages. Like there's There's it's like B, it's just a C or C++ program, so there's bindings to PHP, there's bindings to Ruby, and what we're doing at Airbnb is initially we were just using Node.js. I mean, we're basically a Ruby on Rails shop, and we're using Ruby and Rails as just the JSON API, just that persistence layer. And we started experimenting with Node.js on the server and sharing that app with Node.js in the browser. But we realized, like, we're not going to move our entire app to Node because we've got so much written in Ruby. So we're building a little service that's very similar to what Facebook is doing, where the page is actually mainly a Ruby on Rails page, but then certain bits of it, or maybe even the bulk of it, can be written in React, and we just call out to that JavaScript service, give it data, give it a path to a template, and then we get back a string of HTML that we serve up. Yeah. And then all of a sudden we have a fully server-rendered page, and then on the client side, it can be as dynamic as it needs to be.
There's two really important aspects of this approach that I think are worth mentioning. One is that it can be plugged into an existing stack. So Facebook, we started with PHP because 12 years ago, with Zuck in his dorm room, that was the most popular language. And I'm sure that it was a similar reason for why Airbnb is using Ruby on Rails. All of these places start, in someone's apartment or dorm room, and grow from there. And it's really hard. You can never re-engineer the whole technology stack. You got to start with what you have. So it's really nice that you can kind of just plug in, a call out to the service. The other thing about that's really nice is the JavaScript instance doesn't have to be fully networked. So part of what makes a backend powerful is that it can be the glue that ties together cache layers, database layers, a multitude of services, business logic, that all comes together to build the backend services of your application. And of course, porting it all to Node or any JavaScript runtime is already a lot of work. But also the concepts are going to be different. The APIs are going to be different. The runtime performance characteristics are going to be different. And that one ends up being really important, especially for Facebook, where we've poured tons of time and resources into our PHP virtual machine to make it super fast. And we don't have to really repeat all that work just because we want to run some stuff in JavaScript. So when we run in JavaScript, and like Spike said, it works at Airbnb in a very similar way. We've already collected the data that we want to render, and we just hand it over to the JavaScript process that's running, along with the file that contains React and the React component that we want, and we just get back the HTML string. So it's not actually doing any networking over in the JavaScript space, which makes it really, really efficient to run that way.
That's so awesome. Hey, Spike, I know you probably have to bail out in a little bit, so I wanted to ask you specifically with Airbnb, what kind of issues did your team run into when you guys were trying to switch into this ReactJS mindset? And were there any really big bottlenecks or things like the gotchas that people were you feel like will typically run into when they are trying to implement ReactJS?
Yeah, sure. I mean, there was a bit of a process to get to the point where we could use it in production. Probably the biggest hurdle was just introducing it to our developers and getting their mind around it as a different approach.
I think he's freezing up there.
Can you still hear us, Spike?
Oh, sorry. You hear me now? Did
you
lose me for a second? Okay. I don't know how much you caught there.
Yeah, but, you were paused for a good 5 seconds at least.
Sure. So, but the long and the short of it was, initially it was just getting people used to the idea of JSX. But once people were used to that concept, having XML directly in their JavaScript, it caught on. But then the technical hurdle was we needed a JavaScript build process because we needed a way to transform the JSX files into JavaScript files because JSX gets compiled down to just typical JavaScript. And there's different ways you can do it, but at the end of the day, you need a JavaScript runtime on the server or in your build process to do this. And so at Airbnb, we're a Rails shop, and we typically use Sprockets. Sprockets is the asset pipeline for a Rails app, the open source version of it. But what we've been doing is we've been introducing a node-based asset pipeline, build pipeline, into our build process. and we're using a tool called Browserify. And Browserify is a super awesome tool. You could have an entire podcast series just on it, probably. But basically, it lets you take Node or code that's written for a node and package it up for the web browser. And there's a similar tool called Webpack, which is something that Facebook uses and Yahoo uses, but it's basically the same thing. So once we built that pipeline, that build pipeline that lets us transform JSX files into JavaScript files, and once we got our developers used to the concept, then we were able to use it in production. And it's actually mind-blowing how quick the adoption was on our team. So we introduced it a few months ago, and I think most of the new front-end development across the different product teams in Airbnb has been in React, and that's pretty exciting, pretty quick change, and people just really love writing in it.
That's awesome. And you mentioned JSX was one of the big hurdles, and I feel like that's like the biggest, hardest thing to really to show someone, because as soon as you show them what JSX is, the knee-jerk reaction is separation of concerns. So when I first saw JSX, it literally looks like HTML is written in a JavaScript file, and it pretty much is exactly that. Mm-hmm. But then you actually compile it, and it compiles down into JavaScript classes, and it looks a lot different when you look at them as objects. But when I started getting into it more, though, I started realizing that as I was separating out all these concerns with the Flux pattern, and I had like a certain place for my store, and I had a certain place for my view, a certain place for my dispatch, I started realizing that my views were actually being contained within JavaScript files, but that's all they were. It's like they were very clean, like some markup that was attached to events, but that was it. And I still felt like I still had separations of concerns. Do you guys feel the same way? Do you guys separate your views in your React JS apps?
Yeah, sure. Go for it, Lee.
Sure. So that's one of the biggest hurdles that we help people get over. First, I should say that you don't have to use JSX with React. You can certainly just type regular JavaScript and it works just fine. What the JSX is supposed to be there as a helper. So if JSX isn't for you or you find it not to be helpful, then just don't use it, right? But the reason why people tend to have a negative reaction to it is it's actually the first time that we are assembling UIs as deep hierarchies of objects rather than as stringified templates. And so when people talk about the separation of concerns, often what they're referring to is the separation of technologies, the separation of the technology of templating from the technology of their JavaScript runtime. So if you basically any other front-end abstraction for doing views, you'll find mustache or handlebars or some flavor of this, and the recommendation will be to put that somewhere else because it is in fact a separate technology, a separate language, and there really just isn't a good way to put it into a JavaScript file. With JSX, the first time you look at it, especially since it looks like HTML, you think, that's where the template is. And I've always been told not to put my templates directly in my JavaScript files because it's going to get complicated later on if I do that. And that certainly would be true if it were a template, but it's not a template. What you're doing is you're actually building a data structure. You're building a tree, whereas with a template you're building a string. And they're really different. And you're building this tree. What you're actually building in the tree is you're building the virtual DOM. And later we'll translate the virtual DOM into real DOM. But I found that there isn't actually much concerns to separate within that view. It actually, the code ends up reading similarly to, as I was talking about before, reads really similar to similar code that you would write for the server, and you don't have the same conversation about taking, the code assembling views together on a server and blowing it up and putting in a bunch of different files, unless you're talking about templates, in which case templates always live in their own files. But again, we're not talking about templates here.
And along those same lines, the distinction between separation of technologies and separation of concerns, just because you have, say, your handlebars file, your template in a different file, it doesn't mean they're any less tightly coupled. Like if you've got a backbone view or something, it's still super tightly coupled if you're using, CSS selectors to attach events to things, or you're manually mutating the DOM. Usually there's a very tight coupling there, and the fact that it's in a separate file is actually maybe makes it more difficult to comprehend and to maintain.
The other thing that usually brings up separating these pieces when you're not using React is the relationship between the JavaScript code that controls the template and the template itself. So of course in React there's a very, very tight one-to-one coupling, in which case it certainly does not make sense to detach them, because usually when you separate these pieces it's because you want the ability to reuse them in other places. And if you find views kind of like reaching into each other's guts to pull stuff out, that's the thing we're trying to avoid when we separate concerns. But one React component is likened to like one template fragment, maybe, is the closest parallel to something that uses templates, where the template fragment is actually the thing you care about reusing. And then you might reuse that template fragment in a couple different places and apply different JavaScript behaviors to it later. But when you're talking about a component model in React, when you start to see that pattern, usually what it means is you have a component that's doing too much, and you actually want to break it up into smaller components themselves.
Yep. Well, guys, I actually have to take off. I have to catch a plane back to San Francisco. But maybe if there's any last point you want to touch on.
Yeah, actually, I usually give an opportunity to do a shameless plug. So do you have anything that you'd like to plug?
Sure. Well, I'm going to be at the React Conf, I think next week. You can be there as well, Lee?
I am.
I'll be speaking on a panel about Flux and about how we're using it in an isomorphic way. And then also keep a lookout at the end of the year. I've got a book coming out, an O'Reilly book about isomorphic JavaScript. And so it might be a good place to read up more. And also Airbnb is hiring JavaScript engineers, so come on over.
Excellent. Well, when you get that book finally published, send me the link, and I'll add it to the show notes on the website so it can be linked up there for you.
Absolutely.
So thanks so much for joining us, Spike. This has been super awesome.
It was my pleasure. Thanks, guys. I learned a bit from Lee. It was really great, and hope to see you around the interwebs.
Awesome. Thanks, man. See ya.
Cheers.
Well, Lee, I think we got past the implementation stuff. Do you just want to hammer through a couple of these terms that we've been throwing around, and maybe just
sure, absolutely, yeah.
see if we can get see if we can get everybody on the same page.
Yeah.
Just quickly to hit up, we've been throwing this word DOM around a lot, document object model, and when I was actually going to just throw out a quick blurb of like, oh, this is the DOM, this is what it is, but then I actually was researching it for the show notes, and I actually realized that I didn't really have a good understanding of what the DOM was. Is it correct to say that the DOM is just my HTML markup?
It's not. So I can tell you a little bit about that. So can I talk about JSON as a corollary?
Absolutely.
Okay. So JSON is a string, right? You can take, like, PHP can understand JSON. It doesn't actually say anything about JavaScript. It's just a string. However, eventually you parse that JSON, and you're going to get back out objects with arrays and strings and numbers in them, right, that are deeply nested, so on and so forth. And once you have that, it's no longer JSON. Now it's whatever runtime language you have. So if you do it in JavaScript, you have JavaScript objects and arrays. If you do it in PHP, you have PHP objects and arrays, right? But it's not JSON. So JSON is like the transport format, right? So HTML, there's a similar corollary between these two. So HTML is a string. It's a markup language. It's designed to be parsed by something. And it's a flavor of XML in that way. XML is also a string. Once you've parsed it, it becomes a data structure. That data structure is the DOM. So the DOM, document object model, is the data structure that describes what we usually type out in markup form as HTML. And there's a lot of, the other nice thing is once you have this data structure, if you're talking about the DOM that lives in the browser, there's a really rich API that's been standardized by the W3C that has a lot of really useful methods for working with the DOM. So you can do stuff like, simple stuff like create a DOM node and then attach it as a child to an existing DOM node. But you can also do stuff that might seem simple, but is actually really complicated. Like you can say set inner HTML. And actually what you're doing when you're doing that is saying, I've got a bunch of HTML here. I want you to parse that, turn that into DOM, and then attach that to as a child to this piece of DOM here. That's what inner HTML means. And that's just really scratching the surface. There's a whole bunch of stuff in there. And because it is so complicated, especially the pieces that mutate the DOM, it isn't particularly fast. And that's part of the problem that React helps solve, is that something that lives purely in JavaScript and just JavaScript objects which only live in memory, which is really, JavaScript's really good at operating on data in memory. And then we can figure out what are the things that actually need to change in the DOM, and then call the appropriate mutative methods in the DOM to make sure that the real DOM looks like what we think the virtual DOM should look like.
And the way that it does that is by holding a virtual DOM in memory, right? Basically, it's a representation of what the client is actually looking at, and it does it's diff between that and what the client is actually looking at.
Almost. So what happens is the first time that you render, we will get a virtual DOM out of React, and then React's going to take that virtual DOM and it's going to convert it into real DOM. And the way that it does that is dependent on what environment you're in. So if you're in the server, it's going to turn that into an HTML string and send that to the browser. If you're on the client, it's actually going to create DOM node and assemble these DOM nodes for you on the page. Basically, it's going to do whatever is fastest given the environment. Then on a subsequent render, so something changes about your data and you want to re-render React. So now you're going to get a new virtual DOM of the new environment now that something has changed, and you're going to compare it to the previous one. So you have old virtual DOM, a new virtual DOM, and that's what you diff. So you diff these two things, and you come up with, this piece has a property that changed, this piece has a property that was added, this piece got deleted, this piece got added to this parent. And so it takes what is a sort of a declarative, really, you talked about functional programming before. React really embodies a lot of the concepts of functional programming in that a render method takes in data and returns back out a structure that represents the part of the page that it owns. And later we take these two pieces that were just kind of input-output, and we diff them together to get these imperative, right? Like I'm going to tell you what to do or how to do something rather than what I want. And then the DOM is going to apply those. So take old virtual DOM, new virtual DOM, diff them together, and you get back out add element, delete element, set property, etc.
That whole process is just so ingenious that it inspires me to try to implement some of these techniques into PHP when I write an actual PHP app. And most of it just comes back to just trying to be stateless and not try to maintain state, which is all about functional programming, which we actually had a little episode about functional programming, but I'd like to revisit that in a future episode because I think you can have a whole 50 million podcasts about functional programming and managing state and all that stuff.
Yeah, something that's really awesome about PHP is that it lets you get away with not managing state. That's part of what has made Facebook scale so well, is that our backend being built in PHP was designed from the early days to not hold on to any state. So every time you come back to the server, you're getting like a completely new view, and that mentality is what inspired us to put React together in the first place. Because you build UIs in PHP, and it feels really easy because all you have to do is kind of connect HTML together in the right way. And then send it down. And if something changes, well, you're going to click a link that's going to go back to PHP and re-render the next page. And if you hit the back button, it'll just work because that was a previous page, and everything really just works. And that feels so awesome when you can kind of program that way until you run up against the performance problem of okay, maybe going to the server and then coming back every time I want something to change isn't that performant, especially for something small like I clicked a name in chat and I want another chat box to pop up, and I had to reload the whole page to do that. That sucked. Let's figure out how to move this to the client. But then it sucks when you move to the client, and then the programming model completely changes. So that's really where React came from.
Well, and then speaking of statelessness, though, you actually work on a JavaScript library called Immutable.js. You're a core contributor to that. Is that from what I understand, it's basically models immutable, so read only. So basically, you send it an object, and if you want it to change, you don't change the object, but you send it to this saying this method or whatever, and it'll return a new object for you with the change. So it's a new immutable object. Is that the TLDR version of what Immutable.js is? Yeah,
that's a good description. I'll repeat that kind of briefly. So here's an example. There's a data structure in Immutable.js called list, which is a very, very close, sister data structure to array. Where array, if you call push on an array, you get back that same array. It just added one more piece to it, right? So if you have var a equals some array, and then you can do a.push, 5, you're going to get a is the same array. It's just now going to be one more longer. So if I have variable L equals new list with some stuff in it, and I call L.push5, that's going to return a new list. So I have to hold on to that as L2 or something. And L2 and L are different. So doing that actually returned a completely new data structure, which means the original one never changed. And one of the nice properties about this is, say I have a map, right? JavaScript's actually, weirdly, PHP calls these arrays associative arrays. In JavaScript, we call them objects, although in ES6 there's now a map type that you can use directly. But a hash map, right? Keys and values. So say I have one of these and it's got a bunch of stuff in it, and I say, okay, at key foo, I want to set the value to bar. In Immutable.js, if key is already, or the key foo is already value bar, then it'll just return the same thing back out. So I won't have created a new thing. I'll just get the same thing back out. If it wasn't, well, then it'll create a brand new hash map, and it will make sure that that new key is applied to my new hash map and return me that back, which is great because it means I can just do equality comparison between the previous one and the next one, and I can know if it changed. So I can do that for a bunch of stuff. I can be like, I want to set these 8 keys, and if 1 out of the 8 was different, I'll get it back a new object. If 8 out of the 8 were already set there, I'll get back the same object. And this is really nice in React. React lets you control how that diff process occurs with a component called, a method called should_component_update. So should_component_update is a function that you can add to your React component that takes in as arguments to that function the previous state of the component and then the new state of the component. And then it's up to you to say return true or false. You can say, return false if you shouldn't update. I've inspected the previous and the next state of data and have deduced that nothing will actually change about the UI, and I can go ahead and tell you that everything downstream of here isn't worth diffing because you're not going to find anything valuable. And that ends up being really powerful when you can have that sort of high up in your tree of components, and then just chop off a whole branch of stuff that you would otherwise have to diff. So with Immutable, what you can do is, after you've sort of, somewhere, maybe in Flux, so there's actually a couple of cool implementations of Flux that use Immutable.js. And if nothing changed in the second render, then it just doesn't re-render that part. It just recycles the previous virtual DOM for that particular portion of the component tree, which can dramatically improve performance. So the data structures themselves tend to be slightly slower than their mutative cousins, array and object, but they empower these sort of short-circuit memoization techniques that let us re-render our component in a much, much faster way. And it turns out most of the things that we change about our data structure are pretty small. So I'll click a button and turn something on or off. And I'm really only changing one piece of information, but changing that one piece of information might have the effect of changing huge chunks of my UI. So it's always going to be different in each case, but in the case where the UI is more complicated than the data model, which is more often than not the case, something like Immutable.js or Mori, which is another persistent immutable data structure library for JavaScript, can help memoize these things and make them much more performant.
That's makes a lot of sense, and quite appropriately, you're giving a talk about Immutable.js in terms of React, and I guess Flux as well, right? At the ReactJS conf.
Yeah.
Are they gonna? Go ahead.
I'm just going to say a little bit about what that talk's going to be about, and all the talks from ReactJS will be up on YouTube too.
Oh, excellent! Yeah, I'll make sure to add a link to it.
And I'll be going into how you can use it with React to enable some of these techniques, and then how it actually works. So a lot of people hear that and think, wow, I've got my hash map has 1,000 keys in it, and if I create a new object every time, that's got to be really, really expensive. And it turns out not. We're using a technique called structural sharing, which lets us reuse huge portions of the previous data structure and only actually change the thing that is different. And that's a fairly modern bit of computer science research and super interesting. So I'm going to dive in a little bit and explain how that works in the talk.
That's so cool. I'm excited to see it. So I'm glad that they're going to be posting it on YouTube, because I'll definitely add that to the website a little bit later. It is coming up on an hour, so I just want to kind of wrap it up with a little bit of on Flux, and then if you're watching live and want to pop in and ask questions, I'm going to be posting the link to this Hangout on Twitter here in just a little bit, and and Lee, there's no you don't have to stick around for that or anything, but if you've got time, that's
Yeah,
I've got one of my friends is in particular. We've been kind of learning ReactJS together, and I think he's watching, and I'd love for him to come in because he's a brilliant Perl programmer that I respect a lot, and we have a lot of back and forth on ReactJS and Flux. So
cool.
So when we talked about dispatchers, views, actions, and stores, and all that stuff with Flux, and I think that could go on for a long time talking about Flux. So one of the things I really wanted to learn was, having tried to implement Flux a couple times, is where I put my dang AJAX requests.
Different implementations of Flux put them in different places, and that's fine. Really, Flux is, people talk a lot about Flux being like a big complicated thing, and it's really not. Like, the most important principle of Flux is that data moves in a single direction, and even the details of having actions, dispatchers, stores is relatively specific to a handful of implementations. Some implementations of Flux have gotten by without a dispatcher. Some of them have gotten by without stores even, like the dispatcher goes straight to the top of the React component again. And you see a lot of, and some of them I've seen, don't have any of these, like actions is a fancy way to say a function, and then dispatchers are gone, and then the store is just like Immutable.js or Mori. And they just like have created a data model, and they're just use that, and that's their store. And there's not much to it. So where the AJAX request goes, the common answer is in the action. So the action will dictate how it should communicate with the server. But I've seen some put it in the stores, and I've also seen some put it in the dispatcher. And it's not actually that important as long as the data is continuing to flow in a single direction.
Gotcha. Okay, so I was getting hung up on something that really didn't even matter.
Yeah, it might matter depending on whether or not you're using a library to help kind of like fill in the gaps of the technique. So if you're using a library and it's suggesting that fetches to the server should go in actions, like probably do that to make sure that you're working well with the library. But each library actually has its own flavor of how to do these things.
Cool. Would you say that the main domain logic goes of a Flux architected app would go into the store, or is store's more of like a model though, or like an actual real data model, right?
So it depends. Flux is really good at describing. So really, what Flux is doing is you have your stores, and you should think about your stores as being immutable, which is part of the reason why there are some Flux implementations out there built directly on top of Immutable.js. But you should never think about a store offering an API that lets you kind of change that store. And instead, what the store does is it gives you methods to read from the store, which is what makes sense. So they might be kind of query-ish APIs, right? Like select whatever, filter by whatever. They might be more explicit, like get object with this ID, and then I'm going to go poke around in there and then find more IDs, and then go back to the store and say, okay, get more objects with these IDs. And some of those methods might be derivative, right? So you might have a method that actually itself goes in and takes a couple different fields from your store and adds them together, combines them in some form that's derivative data from the actual store. Actions are about mutating that store. So actions, in order for the app to have life change, the store does actually need to change over time. The thing is that we want all of the logic that describes how it changes over time to live in a fairly controlled place, rather than that store just mutating itself over time, which would be pretty tricky to track how, where all these mutations are coming from, what happens if they collide with one another, things like that. So actions are the places where the mutations occur. And an action has no getters, it only really has setters, right? You create one of these actions, and then you send it off, and that's really it. And then the action describes how it's going to affect the store. So some store implementations will actually have an API where the action itself is really just a description of what should happen, and then the store can take the action and then perform the action. So the store itself might actually implement the logic for how to apply that action, which is part of why I was saying it might, the AJAX request might go anywhere, and in that particular implementation of the pattern, the AJAX request would actually live in the stores, but would only be called via accepting one of these actions. So there are a couple different flavors of how you can use Flux, but that's kind of the dispatcher is really so if multiple stores are interested in the same action, or if multiple actions need to input the same store, the dispatcher can be, the command central to make sure that everything ends up in the right places.
That's cool. It just seems like there's when there's a little bit of ambiguity, it's really hard for people to be like, I just want a black and white. What's the right answer? And it's it just depends.
And part of it too, to be honest, is that this is a fairly new idea that we're doing active research on what the right way to do this is. And every time a new library comes out that does this is awesome, because we can see yet another flavor of how it might work. And there are pros and cons to every one of these, which is great. And if you think about it, MVC is really in the same boat. Like, we keep creating new MVC frameworks. MVC is a relatively old idea in terms of computer science. It's got a couple decades on it now. And really, Flux is different from MVC. First of all, Flux only talks about data flow. It doesn't actually talk much about UI, whereas MVC, the V is about the UI. But MVC is about data flowing to and from the controller. It's about isolating the model from the view and having a controller in the middle that can coordinate the communication back and forth. And so you have data going kind of like in every which way through that model, whereas in Flux, moving in a single direction ensures that you don't have these sort of cascading mutations or cascading actions that can be pretty difficult to control. Stuff that bubbles up in any MVC framework. I spent a lot of time working in iOS and Android apps, and they suffer similar fate as well. So we're actually really interested in taking the Flux pattern and bringing it to other environments as well, not just JavaScript.
Yeah, I started thinking about how I could implement it for my PHP apps, and it's really inspiring. It's an inspiring way to look at a problem. So I don't know. That's one of the reasons why I wanted to talk about it today and see if maybe other people out there in the PHP community might have some ideas about how to implement all this stuff in PHP. But I want to go ahead and move on to the developer shout out, because we had I asked both Lee and Spike to about somebody who we could kind of recognize who has contributed a lot to help people understand ReactJS, or has contributed a lot to the ReactJS community. And so the developer shout out for episode 10 of the PHP Roundtable goes to Jay Longster. Is that right? Is that I'm saying it right?
Yeah, James Long.
Is it James Long?
James Long goes by Jay Longster.
Ah, cool.
He's got a really excellent blog. So everyone should go check out his blog. He spent a lot of time and effort over the last couple of months, especially writing up about React, how it can coexist with a couple other really cool technologies. And it has a really great series on just kind of like breaking it down and explaining how it works, and especially in terms of explaining it relative to other technologies that exist out there for front ends, and like just really cool blogs that have lots of interactive examples in there. Really great resource for learning how this stuff works, especially if you're interested in how the guts work.
Is it jameslonguk.com or?
No,
that's a shopping website.
That's not right. I'll find the URL for his blog and send to you guys.
Cool. I'll definitely have that added to the show notes when I finally get that functionality up on the website. And I have officially lost the window that I was trying to get on here for my show notes. Here we go. Perfect. So do you have any shameless plug that you have for anything at all to promote?
Definitely check out Immutable.js if you haven't. Pretty interesting stuff that's still under active development. So, feature requests happily taken at this point. Excellent.
Well, if you're listening live, definitely check us out for the next episode, which is going to be accessibility on the web. And we'll be talking with 2 deaf developers and 2 accessibility experts on why web accessibility is so important and how we, as responsible web developers, can make the web more accessible. And if you have something you'd like to share about a topic about PHP or anything that PHP nerds care about, we'd love to have you on the panel. So just hit me up on Twitter if you're interested. My handle is SammyK, or just ping PHP Roundtable. So thanks so much, Lee and Spike, who's already gone. But thanks so much for joining the conversation, and we'll see you guys in the next episode.
Sure thing.
That does it for the iTunes version. I just posted a live tweet, or the join us live tweet for anybody listening who wants to join us on the Hangout. And I hope my buddy Glenn is still listening, because I really would love to have him pop in and get his perspective on some of this stuff because he was like at my house the other day and we were hacking away at a project he was working on, and he was just stuck on this issue, and it was with JSX, and like he was having a function that was returning this set of JSX, and it was like giving him this weird error, and we're like, what's going on? What's going on? And looked at it, and he was returning two DOM nodes in the same returns. So like when it went to render, you can't like return two objects in the same return in JavaScript. So
Yeah.
that whole comment that you made about like not thinking of JSX as the view, but more of like you're like coding like your
Yeah.
I don't know what the word was you used, but
think of it as an object. It's a data structure.
a data structure. Yeah.
So when you think about the stuff in terms of HTML, you just think about it as strings, and if your string happens to have two div tags next to each other, whatever, it's just a string, right? But actually, once you parse that, it's an array of nodes, and that's a limitation of React's reconciliation algorithm, or its diff algorithm, is that each component needs to be representative of one and only one node. We want to fix this in the future, but we haven't quite figured out a way to do it that won't cause performance issues.
Right.
But we want to have the ability to return a collection of HTML nodes from a single component. We'll still need to wrap it in something. So of course,
Right.
that JSX it translates to just JavaScript objects. So you of course can't return return objects and then enter object and expect that second object to show up. So we'll warn for you, and so we'll have to come up with something to wrap it. I don't know, maybe as simple as wrapping it in an array. Maybe we'll have something like a fragment, which is commonly understood in HTML lingo. We're figuring that out, though. Lots more to do in React.
That's so cool, and it's so progressive. It changes so much that I guess the beautiful thing is that it is kind of changing, getting better, but it is changing so fast that sometimes it's hard to kind of keep up with all the changes that are going on. And there are a couple of breaking changes that happen every once in a while, right?
Yeah, we're trying to both release more often and be mindful of how we release. So React follows semantic versioning, kind of, but part of what we are trying to do is and every time we release a new major version that will have breaking changes, we support the previous version. So we'll always have like one version prior support, but we might flood your console with console warnings, explaining to you what changed, why. There's usually a link in there to like a wiki page or something to explain what happened differently. And these changes are usually pretty subtle. They're React steps forward. We kind of know where we want React to end up, and we know that there are a handful of things where we had made a decision that's just incompatible with where we want to go next, and we're going to have to break people through it. And hopefully we can do it in such a way that as we progress through the versions, warn them step by step along the way, and eventually the warning disappears and it just becomes a breaking error. But hopefully, as long as you kind of keep up version by version, you'll actually like see these things come up. So it ends up being a fairly different model from working with some other libraries, where once you find the version of the library that works for you, you just kind of stick with it. And certainly you could do that with React if you wanted to. But if you want to stay on the latest version, it's actually in your best interest to, every time a new version of React comes out, make sure you update that everything on your site works with it. Everything should work right off the bat, actually. Like one version bump up, as long as it wasn't a warning in the previous version, it should work. If it's not working, it's a bug, report it. And you'll start to see warnings in your console, only in the developer version, not the minified production environment, actually. So shouldn't see performance degradation from that. And it'll help you keep track of the things that are changing in React over time. And we launch a new version maybe every couple months. So not so frequently that like every week or two you're like turning around and redoing everything. And otherwise, we try to only release critical bug fixes. And of course, you can always track master from GitHub and have the latest and greatest, which we do at Facebook. So Facebook runs not from the latest production release of React, but from master. So if master's broken, Facebook's broken. So the quality of master is usually very high.
That's cool. And the guy I see committing so much in there, Ben Alpert, I think is his name. Is he doesn't even work for Facebook, right?
Ben works for Code Academy.
Oh, okay, cool. And because they use ReactJS as well, because I think there's somebody, at least one or two people speaking about their transition to React.js at the React.js conf, I think.
Yeah, yeah, they've built some
So,
really awesome stuff.
and that's so cool that since it's open source, you just kind of like everybody just pops in and just commits away.
Yeah. So Ben is part of the core team now, actually. So
Oh, excellent.
we have our weekly meetings for React core contributors, and we make sure that Ben comes over to Facebook and gets to join us in the room for those. And he's been doing that for the last couple of months. So it's actually great. Like we're trying to, people kind of like bubble up in the community who work that way, but it just so turns out that Ben is awesome and contributes quite a lot, and we make sure that he's included.
That's cool. Yeah, I just see tons of commits from him, and he's very active. What actually do you contribute to the most in React.js, the project?
So the thing that I am probably most visible for doing is assembling the component API. So if you see all the names of all the component methods and then the life cycle of the components and how those work, I spent a good deal of time making that work, and have also spent a fair amount of time in the reconciliation algorithm, so the thing that actually diffs the trees together once something changes, and making improvements to that. But most of what we're doing now is sort of like slow and steady and improving towards something that we know about. So a lot of our work these days are figuring out just what we want JavaScript to be in general and how React fits in with that, and then either taking those things to standards bodies to talk about them, or figuring out ways to integrate them into React to sort of illustrate the point so that we can then take them to standards bodies and integrate them. Because what we'd like to see is React get smaller. A lot of what React does is kind of like patch over differences between browsers, and we love for that stuff to go away over time. It's also, right now you build these things by doing this react.create class, and then you kind of like pass in a object full of methods. We just want to replace that with the new class syntax that's coming out with ES6. So there are all these things that we can do to make React actually lighter weight, but by taking the concepts that are in React and just moving them into JavaScript proper. So that's kind of what we're working on now, and I've been spending some time kind of working with that process.
Nice. Were you the one who came up with the method name dangerously set HTML, or I can't remember what it's called specifically?
I am not. However, that is the oldest method name in all of React Core, because that one comes from from XHP. So I mentioned before that JSX and really React in general is inspired by the work that we've been doing on our PHP front-end infrastructure. And in PHP, we used to just concatenate a bunch of strings together, and we would have XSS holes. There are actually a handful of Facebook employees that were famously hired because they found and exploited the XSS holes, and we decided to hire them because they were smart. And XHP closes up the holes because you're not, when you're building templates, you're building HTML. When you're building with XHP or JSX, you're building DOM. And as I explained the difference between those two, HTML is just strings that you blob together, and it's really easy to make a mistake and have a malformed HTML, which is where XSS holes come from. But when you're assembling a DOM, it's not possible to create an incorrect DOM, right? Like you call a method on the DOM, if it's wrong, it's going to like bork at you. If you build like an inappropriate DOM tree, you're not going to, it won't render. So the one drawback with assembling DOM rather than assembling HTML is when you just like have a blob of HTML you need to render. A great example of this is like Markdown. So like you have Markdown, you render the Markdown comes back out as just strings. And you have this HTML string, and you want to like put it in your React app, or you want to put it in your JSX, or your XHP on your backend. And you can't, because it's not XHP, it's not JSX, it's just a string of HTML. Where do you put it? And so you need some way to bridge between the world of assembling DOM and the world of building HTML, which is the same idea as inner HTML as a like a property that acts kind of as a setter method in the DOM API. So dangerously set inner HTML was introduced as part of assembling XHP. So XHP, the first thing that we had was this an XHP node called HTML, not to be confused with the root element of your page, where you could set the contents of that HTML. And that was the beginning, and the API it read very nicely. It was just like, okay, HTML content node here, contents equal, name of string. And then, some engineer would come along and build most of their site using that, and they would introduce an XSS hole. So a common way to thwart badness in the Facebook code base is by renaming methods to seem scary. So
Yes.
We changed it from HTML content to dangerous HTML content, and that caused some of them to go away, but others chose not to pay attention to that. These days, the name of that XHP component is actually called dangerously insert XSS hole. Is what we've renamed that to.
That sounds really scary.
Yeah, so we toned it down one notch for React and just called it dangerously set inner HTML, and we made it sort of purposefully opaque. And there's also another quirk that you have to do when you're using dangerously set inner HTML, is you have to wrap your string in an object with a thing called HTML colon and then the thing there. You can't just put a string there. And there's also a historical reason for why that exists. That also comes from PHP, where we had a PHP class called HTML that simply had a single field on it called contents, or I think it must have just been called the HTML, which is where it carried over from. And when you were rendering an XHP, we would actually check. So if you use this dangerously insert XSS hole tag, you had to not pass it a string, but it actually took a HTML instance, HTML, this PHP arbitrary PHP class that we named HTML, and we would actually do like an instance check. We'd get the class name of the thing you passed in, and if it wasn't HTML, we would throw, because people would just pass arbitrary strings in, and this way we could kind of track along, methods that were allowed to operate on HTML-looking things versus those that weren't. So that got carried over as well. Actually, in a previous version of React, there was, in fact, a whole class to define these HTML things. We thought it was a little bit heavy, and it was nicer just to wrap it this way. But it ends up making it really nice if you use TypeScript or if you use Flow, and you want to type, things that go in and out of this function are HTML versus any other arbitrary string, so I don't accidentally make a mistake and inject an XSS hole into my app.
That's so crazy that I didn't know that there was such a history behind that, the name of that method, by the way, because I was going to say that I was inspired by that method, and my own contributions to the Facebook PHP SDK has a method in it that I created called dangerously set params when it's manipulating the URL.
Cool.
And that was inspired by dangerously set inner HTML from React.
It's come full circle, so you've contributed back to Facebook open source code using a technique that is very popular within the Facebook walls.
Somebody that doesn't even work for Facebook caught on to that. That's crazy. That must mean you got a strong culture there, so that's a good thing. Well, Lee, I have got to pop off here, and I really, really appreciate you coming on and talking about this. This is it's inspiring, and I hope it's inspired others to go down the ReactJS holiday and fanboyism.
Yes.
And we'll be looking forward to your talk at ReactJS, and I'll add that conf, and I'll add that to the website as soon as it's up.
Cool.
Cool. Thanks again. Talk to you soon.
Yep. Thanks for having me.
All right. Bye-bye.